Good day, favorite. Welcome back to another episode. All right, today we are talking about gravitational field. Gravitational field is a region around a mass in which the gravitational force of that mass can be felt. Okay, in this topic, I'm going to bring out the required equation necessary for this topic, and then before we start executing problems. Okay, first, let's start from Newton's law of universal gravitation. According to Newton, everybody in the universe attract each other with a force that is directly proportional to the product of their what masses and inversely proportional to the distance, to the square of the distance between them. So if I remove this proportionality symbol, I impute a what? A constant is equals to what? G m over what? R square. Now this is the first equation we put in mind. For this is equals to what? G m over what? R square. The first equation we need to put in mind, Newton's law of universal gravitation. Now we use this to elaborate more, according to Newton, about the movement, about the force of attraction between the moon and the earth, and the earth and the sun. You see the movement of the moon around the earth. The moon keep moving around the earth. It refuse to leave the earth. And it's not tired of moving. It explains that it means that there's a force that binds these two bodies together, that they can't leave each other. The same thing with the earth and the what? The sun. So this is the mass of the bigger body, while is the mass of the smaller body. This one is taking capital letter, this one is taking small letter. Then this G, this D is a what? Is a constant. We call it gravitational constant. It has a value of 6.67 times 10 raised to the minus 11 Newton meter square per kilogram square. Right, this is the value for G. It's a constant. Now there is a what? A difference between this G and this. Now let's talk about what? The relationship between these two. G and what? G. This one is capital letter G, while this is small letter g. This capital letter G, this is what? Gravitational constant, while this small letter g is what? Acceleration due to gravity. Or what we know as, we also call it force per unit what? Mass, as the case may be. It's the same thing. So, for this, let's say this one is acceleration due to gravity for a body on Earth. Now, let us consider a body on Earth. For a body on Earth, let's say this is Earth, while this is the body on Earth. The force of attraction between these two, the distance between these two bodies is the what? The radius of the what? Earth. That's the radius of the Earth. Now, from this equation, I'm going to bring out the relationship between these two. Now, so we know that from this, for a body on Earth, is equals to what? G, and this is the mass of the Earth, mass of the body over what? Radius. For a body on Earth, let us use radius of the Earth. Let's use capital letter R for radius of the Earth. For a body on Earth, it's going to be what? Mg as weight. So therefore, this is mass of the body, cancel that. So therefore, G is equals to what? G m over what? R square. Now, this is the relationship between what? Acceleration due to gravity and gravitational what? Constants. So, we'll put this in mind. Another equation, this is G equals to what? M over what? R square. Put this in mind. Okay. Now, another thing we need to note that this acceleration due to gravity, it varies. It changes. Okay, now, variation of this acceleration to gravity with what? Latitude. Latitude, we are talking about what? Height, increase in height. Okay, as the case may be. Now, for a body on Earth, this guy varies. It changes. For a body on Earth, the acceleration due to gravity is what? That is G equals to what? M over what? R square. Now, for a body with if this body increase in what latitude or increase in altitude, as the case may be, increase in altitude, that means increase in height. So this is what the Earth. Okay, let's say the body is somewhere around here. Now, the distance between these two is going to be the what? The radius of the Earth, which is capital letter R, plus the what? The height. So for this concept, the acceleration due to gravity, okay, let's call this concept G prime, with increase in what? Latitude, with increase in altitude is what? That is G m over what? R, radius of the Earth plus what? Height, raised to the power of 2. Now you can see that these two, they are not the same. Let's call this one equation 1. Let's call this one equation 2. Okay? So if I divide equation 2 by equation 1, let's divide equation 2 by equation 1. Okay, equation 2. The left-hand side we divide, while the right-hand side we divide each other. So this is what? G prime over what? G equals to, then this guy will divide this guy. So this is what? M over what? R plus what? H raised to the power of 2 divided by this guy. So we don't even change it to multiplication, and going to take the inverse. R square over what? G m. So these are constant, we cancel out. So therefore G prime over what? G is equals to R square over what? In brackets, R plus what? H raised to the power of 2. Now, see this equation. If we really observe this right hand side, we discover that the denominator right here is greater than the numerator. Now this is a what? A proper fraction. The denominator is greater than the what? Numerator. Anytime in a fraction the denominator is greater than the numerator, that value is not greater than 1. It's not up to 1. For example, 1 over 2, denominator is greater, is equal to what? 0.5. It's not up to 1. So this value here is not up to what? 1. This value here is less than what? 1. This is less than 1. I can say that G prime over what? G is what? Less than what? 1. This is less than 1. Therefore, G prime is less than what? G. That means the acceleration due to gravity here, which is G, is greater than the acceleration to gravity here, G prime. This guy is greater than this guy. This guy is less than this guy. That means anytime a body increase in what? Altitude, the acceleration due to gravity do what? Decrease. So what are we talking about? Acceleration due to gravity decreases with what? Increase in what? Altitude, or increase in what? Height. So let's put that in mind. G prime is less than what? G. Okay. All right. So we move to the next one. Gravitational field strength. Gravitational field strength. For gravitational field strength, it's very easy. That is what? E subscript G. It is what? Force per unit what? Mass. And it's measured in watts. That is Newton per kilogram. Newton per kilogram. This is the power of 2. Newton per kilogram. So that's what gravitational field was. Strength. Now let's talk about what gravitational potential. Gravitational potential. Gravitational potential at a point. That means we are talking about, it's defined. We are talking about the potential of a what? Of a unit mass. The potential in taking a what? A unit mass from infinity to that point. Or we can say the gravitational potential is the what? The work done of taking a unit mass from infinity to that point. So therefore, gravitational potential is equals to what? Work done. Work done over what? mass. So this is the word gravitational potential, work done over mass. So therefore, what is work done? Work done is what is work done? That is mgh over what? Mass. So mass, we cancel out mass. This is equals to what? G times what? H, the height, the distance. So let's use what? Arrow for what? Distance. Now this is what? Gravitational potential. And what is G? This is G. So therefore, V is equals to what? This is G m over what? Arrow square times what? Arrow. So we are still using radius of the earth. So therefore, this will cancel this. So therefore, gravitational potential is equals to what? G m over what? R. Now this is the what? Gravitational potential. So we put this equation in mind. V equals to what? G m over what? R. In most cases, we put a what? A negative sign here. Negative sign here. Now this negative sign indicates that the potential at infinity is higher than that which is close to the unit mass. So that's the meaning of that word, negative sign. Okay, let's go to the next one. Which other equation? Which other one? Escape velocity. Escape velocity. Now, by escape velocity, what are we talking about? We're talking about the minimum velocity of a body to leave or escape an astronomical what? Body. That's the minimum velocity for a body to leave the gravitational field of an astronomical what? Body. So that is what? Escape velocity. Like for instance now, for we to get out of this earth, the gravitational field of this earth, we need escape velocity. We need to escape. You know that this earth, if you look at it in a way, it's like a prison, a very big prison. So for human beings, so we live on this earth, we do everything we want to do on this earth, we die on this earth, we are going to get buried on this earth. So for we to leave this prison, we need what? Escape velocity. Okay, my fellow prisoners, now listen. The astronomical body, we are talking about what? A planet, for example, the Earth. And the body that is living, for instance, let's say a rocket, as the case may be. Okay, escape velocity. That brings us to work done. Work done. First of all, what is work done? I'm going to bring out the equation. What is work done? Work done is what? Force times what? Distance or displacement, as the case may be. So therefore, work done is equals to, what is the force? This is the force. Now this is the force, which is what? G m over what? Arrow square. That's what distance. The distance, the same thing as arrow. So therefore, this will cancel at this. So therefore, this is the work done equals to what? G m over what? Arrow. Now this is work for what? The work done. Now this work done is equals to what? The kinetic energy of the body possessing the what? The velocity, the escape velocity. Now is equals to the kinetic energy of the body possessing what? The escape velocity. What is the kinetic energy? Formula for kinetic energy is what? 1 over 2 mv what? Square. Now this is the what? The escape velocity. V subscript E equals to what? G m over what? R. Now this is mass of the body, cancel that. So if I make this velocity subject formula, escape velocity subject formula, is equals to what? Square root, I have 2gm over what? R. Now this is what? Escape velocity. Okay, let's make this thing look more beautiful. This is mass of the earth, isn't it? And here's what? Mass of the earth. From here, let's make mass of the earth subject formula from here. Mass of the earth will be equals to what? G arrow square over what? Gravitational constant. Now this is the mass of the earth. Now let's substitute right there. So therefore, V acceleration escape velocity equals to, so I have square root 2g over what? R. 2g over r, we are using what? Radius of the earth, because the body will be on earth before escaping. Radius of the earth, okay, we are here, times what? The mass of the earth. What's the mass of the earth? G r square over what? G. So G will cancel out G, R will cancel out R. So therefore, escape velocity is equals to, I have 2gr. So this is what? Escape velocity. So therefore, I have it right here. Escape velocity is equals to, you have the square root 2g r. Escape velocity. Okay, I'm going to stop here. So we'll stop here for today. So in our next class, we are going to do what? Solve questions in relative to this what topic. Please follow. Just follow. If you get to see more about me, make sure you hit the follow button. It does not cost much. And also subscribe to my YouTube channel. Everything you need to know about. There's a lot of topic on my YouTube channel. Just click on my bio. You are there. Subscribe. You see many topics that are there that you need to know about in physics, mathematics, and further maths. I remain your favorite tutor. Thank you, and God bless you.